On the morning of December 26, 2004, the sea near Indonesia seemed to vanish. The shoreline stretched unnaturally far, leaving fish flapping on bare sand. Families wandered out, puzzled by the retreating water. Within minutes, the horizon darkened. A wall of ocean, higher than the palm trees, roared forward like an unstoppable beast. When it struck, houses splintered, cars floated like toys, and whole neighborhoods disappeared. Survivors would later describe the sound as 1,000 trains thundering at once. By the time the waters receded, more than 200,000 lives across 14 nations had been claimed. This catastrophe raised a haunting question. How can the same ocean that nourishes us suddenly unleash such unimaginable violence? What lies hidden beneath its surface that transforms calm waters into a weapon powerful enough to sweep away entire cities? To answer this, scientists make a crucial distinction. Not all giant waves are born equal. Tsunamis erupt when something, an earthquake, a volcanic eruption, or a landslide, pushes an enormous volume of water upward, setting off waves that race across oceans at jetliner speed. In contrast, rogue waves, often called mega waves, form mysteriously in open water when multiple waves converge, stacking their energy into a sudden, towering wall. Both can be deadly, but they come from very different origins. This documentary is a journey to uncover the science behind these watery giants. From ancient legends of gods punishing humankind to modern satellites tracking waves in real time, we'll explore how researchers try to decode the ocean's most destructive mysteries. Because to live beside the sea is to live beside both beauty and danger. And only knowledge can prepare us for the next great surge. For as long as people have lived by the sea, the ocean has carried both promise and peril. Ancient cultures tried to explain its sudden fury with stories of gods and monsters. In Greek legend, Poseidon's anger could summon waves to sink ships in seconds. In Japan, villagers spoke of Namazu, a giant catfish said to thrash beneath the earth, shaking the seas above. Across the Pacific, Polynesian chants described islands swallowed whole by the ocean's wrath. These myths were more than folklore. They were warnings, passed from generation to generation, that the sea could one day rise without mercy. For centuries, coastal communities were caught unprepared when such warnings turned real. In 1755, Lisbon, Portugal was devastated by an earthquake and tsunami that killed tens of thousands. In 1883, the eruption of Krakatoa sent waves across the Indian Ocean, leaving villages reduced to splinters. Fishermen returning home often found their harbors gone, replaced by fields of wreckage. Without science to explain what had happened, survivors could only frame these disasters as fate or divine punishment. One witness to the Lisbon disaster recalled, "The sea itself turned against us, and nothing could stop it." Over time, patterns began to emerge. Certain places were struck again and again, while others remained untouched. Japan, Indonesia, Chile, Alaska, and the Pacific Northwest formed a silent map of danger zones, all linked by restless tectonic boundaries. These became the world's tsunami hotspots, regions where earth and ocean collided with terrifying regularity. Life there meant living with constant unease, where the rumble of the ground or the sudden retreat of the sea could mean the difference between survival and catastrophe. It wasn't until the 20th century that scientists began systematically studying these waves. Early seismographs revealed the link between earthquakes and tsunamis, while tide gauges offered the first crude measurements of water surges. By mid-century, researchers in Hawaii and Japan started categorizing wave types, laying the foundation for modern tsunami science. What was once seen as myth or mystery slowly became measurable, explainable, and, crucially, predictable. The birth of this scientific inquiry marked humanity's first real step toward understanding, and perhaps, one day, controlling, the sea's most destructive power. Beneath the world's oceans, the ground is not still but alive. Earth's crust is broken into massive tectonic plates that grind, collide, and slip past one another. Most of the time, these movements go unnoticed, hidden deep below. But when the stress becomes too great, a sudden rupture can jolt the seabed upward or downward in an instant. This violent motion displaces billions of tons of seawater, sending energy racing outward in all directions. Unlike a surface ripple, This surge carries its force throughout the entire depth of the ocean. Scientists describe it as a moving wall of energy, invisible in deep water but capable of traveling faster than a jet plane. These submarine earthquakes are the most common and powerful creators of tsunamis, rewriting coastlines in the blink of an eye. Yet earthquakes are not the only culprits. Sometimes it is fire that awakens the waves. Volcanic eruptions, like Krakatoa in 1883, blast entire islands apart, shoving the ocean aside with apocalyptic force. At other times, Earth itself slides into the sea. Underwater landslides, triggered by instability or quakes, can hurl masses of rock and sediment into the depths, producing sudden waves. Even from the heavens, danger exists. A meteor plunging into the sea would instantly generate a mega tsunami, dwarfing anything in recorded history. While rare, such possibilities remind us that tsunamis can be born from many different sources, each one capable of chaos. At the heart of these events lies the physics of wave growth. In deep water, a tsunami may appear only a meter high, barely visible against ordinary swells. But its wavelength stretches hundreds of kilometers, carrying energy silently across entire oceans. As the wave approaches shore, the seabed rises. Energy once spread across deep water is compressed into shallows, forcing the wave upward. What was once an unremarkable ripple becomes a towering wall of water. The momentum is staggering. Buildings crumble, ships are tossed inland, and entire landscapes are redrawn. Not all giants, however, are tsunamis. Out in the open sea, sailors have long whispered about rogue waves, walls of water appearing without warning, seemingly from nowhere. For centuries dismissed as myth, modern instruments have confirmed their reality. These freak waves are born when wind, currents, and normal swells combine at just the right moment, stacking together into a single monstrous crest. Unlike tsunamis, rogue waves are not tied to earthquakes or volcanoes. They can strike in the middle of a calm sea, swallowing vessels whole. A scientist once described them as the ocean rolling its dice, and sometimes the result is deadly. To understand these phenomena, researchers turn to data. Historical records provide chilling case studies. The 1960 Chilean earthquake sending tsunamis across the Pacific, the 2011 Tohoku disaster overwhelming Japan's defenses, and rogue waves like the Draupner wave in 1995, measured at over 25 meters high. Each event feeds into computer models that simulate how water moves, how energy transfers, and how coastlines respond. These models are tested against real-world data, sharpening our ability to predict the unpredictable. Technology now forms humanity's frontline defense. Networks of deep-sea buoys, known as DART stations, monitor changes in water pressure as tsunamis race overhead. Satellites track subtle shifts in the sea's surface, while seismographs instantly detect earthquakes that could trigger waves. High-powered computers run simulations, estimating arrival times and potential heights within minutes. Warnings can be issued, lives can be saved, but only if communities know how to act. As one oceanographer explained, "Science gives us the alarm, but people must know when to run." Together, these tools reveal a deeper truth. The ocean's fury follows rules, however complex. By studying restless plates, violent eruptions, sudden landslides, and rogue waves, humanity inches closer to understanding. Yet even with our knowledge, the sea retains its mystery. For every answer uncovered, new questions emerge, reminding us that the ocean is both a frontier and a force. When a tsunami strikes, it is not just water that rushes ashore. It is devastation carried on a moving wall. Streets vanish, houses collapse, and families are torn apart in seconds. Survivors often describe a silence afterward, broken only by the cries of those searching for loved ones. The 2011 Tohoku tsunami in Japan left entire towns erased, their maps suddenly useless. In Banda Aceh, Indonesia in 2004, survivors walked through fields where neighborhoods once stood, unable to recognize their own homes. One witness recalled, "I could not find the street I grew up on. It was as if the ocean had erased memory itself. Lives shattered, cities swept away. The human toll is always the first and most painful consequence. But destruction does not end with people. Nature itself is redrawn. Coastlines carved over centuries can change in minutes. Saltwater invades farmland, poisoning soil for years to come. Estuaries, once nurseries for marine life, are smothered in sand and debris. Coral reefs break beneath the force of debris-laden waves, while mangroves, natural barriers, are ripped out by their roots. Entire ecosystems collapse, leaving fish stocks depleted and wildlife displaced. The sea does not just reclaim land. It alters the very fabric of life along its borders. Then comes the long shadow of economic cost. Bridges and highways lie broken, ports are crippled, and power lines are torn away. For many nations, especially developing ones, rebuilding can take decades. In Japan, the price of recovery after 2011 reached hundreds of billions of dollars. For poorer nations like Sri Lanka or Haiti, the losses cripple national economies for generations. Insurance systems collapse under the weight of claims, and small businesses vanish forever. As one economist observed, a tsunami does not just take lives, it erases livelihoods. Faced with this reality, humanity has turned to preparation. Coastal nations have built networks of early warning buoys, satellites, and seismic monitors. Sirens now stand along beaches, ready to sound when danger looms. Communities run evacuation drills, children taught to recognize the sea's retreat as a sign to flee. International cooperation has grown stronger, with warning centers in Hawaii and Japan sending alerts across the Pacific within minutes. Scientists stress, however, that warnings are only useful if people respond. A Japanese researcher put it simply, technology can give time, but culture must teach action. Yet even as defenses improve, the risks ahead grow larger. Climate change adds a dangerous layer of uncertainty. Rising sea levels mean future tsunamis will reach further inland, even if their size does not change. More people than ever now live in coastal megacities, placing millions directly in harm's way. Warming oceans may alter storm and wave dynamics, though the connections remain under study. What is certain is that humanity's footprint along coastlines is expanding, even as the seas themselves grow more volatile. The future, perched at the edge of rising tides, holds challenges unlike any faced before. The story of tsunamis and megawaves is not only about the past, it is about the choices we make now. From shattered lives to altered landscapes, from rebuilding cities to preparing for tomorrow's disasters, every decision carries weight. And as the climate shifts, the stakes will only grow higher. Science has come a long way from the days when coastal communities had no warning at all. Today, satellites scan the oceans, buoys sense the smallest ripples, and algorithms race to predict where waves will strike. What once seemed like acts of divine punishment are now better understood as the natural consequences of a restless planet. Humanity has gained precious minutes of warning, moments that can mean the difference between life and death. In this progress lies proof of how far science has come, yet beneath the waves, mysteries remain. The deep ocean still hides secrets of how energy travels, how seafloor faults interact, and how rogue waves rise suddenly from calm seas. Even with advanced sensors, the ocean often outpaces our models, reminding us of its untamed complexity. As one oceanographer explained, we can map the stars above with greater accuracy than the trenches below. The greatest laboratory for the future remains the sea itself, but knowledge is only powerful when shared. The future will demand cooperation between nations, between scientists and policymakers, and between communities and their coastlines. From Pacific islands to bustling megacities, humanity must work as one. Building stronger infrastructure, funding global monitoring systems, and spreading education about evacuation are not luxuries. They are necessities. A safer world rests on cooperation across borders and across generations. Still, no wall, no satellite, and no model will erase the truth. Humanity lives in the shadow of the ocean's power. For all our progress, the sea remains master of its depths. But awareness is no longer fear, it is preparation. And in that preparation lies resilience. The question that remains is not whether the waves will rise again, but whether we will be ready when they do.